So the polar front theory, the mid-latitude cyclone form on a boundary between warm and cold air. So the polar front shift towards the equator as the high pressure system dominates more in the summer. So this is how polar front theory explained over the United States inland the mid-latitude cyclone form. So the development of a mid-latitude cyclone, according to the Norwegian model, it begins along the polar front, and the polar front actually is a semi-continuous global boundary separating cold polar air from the warm subtropical air. So mid-latitude cyclone storm form and moves along the polar front is a kind of wave-like manner. So that's why the developing or of the storm of the mid-latitude storm, we call it a wave cyclone. And the next we will be explaining each of the stages of the developing wave cyclone and the weather map in a sequence.
In the very primary model, that's the stationary front, this picture A is showing that segment of a polar front as a stationary front. This stationary front is representing a trough of lower pressure with the higher pressure both sides. That's in the middle. You see the lower pressure, that's low pressure is indicating the trough, and both sides we have high pressure. So the cold air to the north and warm air to the south is flowing parallel to the front, but these two sides is flowing opposite direction. These types of flow actually sets up a cyclonic wind shear, and if you can conceptualize this shear by putting a pen between the palm of your finger of your hand and slide it to the left palm towards your body, then the pen turns counterclockwise cyclonically. So since the stationary front form, the next stage of developing cyclone is frontal wave cyclone. So in here you will see the cold front and warm front actually placing here. So under any right condition of these in here, a wave like kink form on the front. If you're looking at the picture, the wave form is known as frontal wave, or you can say incipient cyclone, the very beginning of the cyclone. So this 12 point B figure is showing a newly formed wave with a cold front that is pushing southward and a warm front that moving northward. So again, a cold front is pushing southward and a warm front is moving northward. So in here, the lowest pressure, you can call it central pressure, is at the junction of the two front. So as cold air displaces, the warm air is upward along the cold front, and as overrunning occur ahead of the warm front, a narrow band of precipitation you can see the forming over the green shaded area. It is steered by the wind, is upper wind, and the whole system typically moves the east or northeastward and gradually become a fully developed open wave in 12 to 24 hours, as you see in the sea or the open wave. In an open wave, precipitation form in a wide band in front of the warm front and in a narrow band along the cold front. So the region warm air between the cold and the warm front is known as warm sector. This is very important. What is warm sector? So in between cold and warm front, there is a region of warm air, that's called warm sector. So weather tends to be partly cloud in here, and scattered shower, you can see thunderstorm maybe, and air is conditionally unstable. But the energy of this warm sector and the open wave comes from the storm is several sources. The air mass try to attain its equilibrium situation. The warm air rises and the cold air sink, and transforming the potential energy into the motionic energy, which is we called is kinetic energy, the energy of the motion. And there's another source is condensation that supply energy to the system in the form of latent heat. And the surface air converges towards the low center. Wind speed increases in this process and produce a increased kinetic energy. So as open wave moves eastward, its central pressure continues to decrease and wind blow more strongly as wave quickly develop into mature cyclone you are seeing in the picture D. The fast moving cold front constantly come to closer to the warm front and squeeze the warm sector into a smaller area. If you're looking at the picture D, in this model the cold front eventually overtake the warm front. We know that when cold front overtake the warm front, it's sometimes it's create the occluded types of front and the system become occluded. At this point, the storm is usually most intense, most strong, with clouds and precipitation over the area. The area is more intense weather is normally found in northwest of the storm center, and a strong wind that is blowing and drifting snow is creating blizzard condition in the winter situation. So in the mature initial occlusion, the wind blow very strong and warm sector actually become smaller, squeezing smaller, and occluded front system create a lot of precipitation, and sometimes it's a thunderstorm you can see there. And next stage is advanced occlusion, the point of occlusion where the cold front, warm front, and occluded front. So cold front, warm front, and occluded front, all front come together. If you're looking at the picture E, is referring as a triple point. It's the low triple point under the low. And if you notice that region cold and warm front appears similar to the open wave cyclone. And open wave cyclone, you can see if you look at the picture C, you can say open wave cyclone. It is here where the new wave, we call it secondary low, will occasionally form, and this whole system moves eastward or northeastward, and the whole system intensified into cyclonic storm. So this cyclonic storm, in right now we need to fuel up with the warm air, but when we do not have that, then we will see the cut off of the cyclone that is actually separating from the warm sector, and this cyclone doesn't have the fueling to sustain for over long time, and it is becoming a dissipate and dying out cyclone. So in a nutshell, we can say that stages of developing mid-latitude cyclone, the first stationary front happens when we have a trough, and on the both side we have a high pressure system, and then frontal wave happen because cold front is moved to the southward and the warm front to the northward, and over here you have a steering low pressure with some precipitation, and then it moves to open wave and create a warm sector, the warm air between the cold front and the warm front, that's called warm sector. Then this warm sector is the fueling of the mature initial occlusion of the cyclone, and then this low pressure intensified over here, and then advanced occlusion happens. Occlusion means the cold front is overtaking warm front and occluded front happening, but in this stage if we would like to sustain our cyclonic storm more longer, we need a very strong warm sector, but the warm sector is actually cut off from the triple point, cut off, and then it's dissipate at the final stage. So this is the simple version of the Norwegian polar front theory model, and we have a picture. Next slide. So in this figure, it shows that a series of wave cyclone in different stages of development along the polar front in the winter. So such a succession of the storm is known as family of cyclone. So if you are looking at the north of the front are cold anticyclone, and to the south over the Atlantic Ocean is warm. So semi-permanent Bermuda high, you can see that. The polar front itself has developed into a series of loops, and the highest each of the loop is cyclonic storm system. The along the east coast, if you are looking at the cyclone over the northern plain, which is indicating low 1, is just forming, and the one along the east coast, that's low 2, is an open wave, and the occluded system near Iceland, which is indicating low 3, which is actually dying out. The cyclonic system is dying out. So if the average rate movement of the wave cyclone from birth to dissipate or die or decay is about 25 knots, then it is entirely possible for a storm to develop over the central part of the United States, and it is possible to intensify into a large storm over the New England state. It is possible that this cyclone become occluded over the ocean, and it is possible that it can reach the coast of the England in its dying stage less than a week after it is forming.